Good morning, mathematicians. How we doing? Yeah, new episode, new day, second morning in the new place. First day of the semester officially. Good morning, mathematicians. How we doing? And what to talk about? What to talk about today? Hello, Ed Smith. Good morning, good morning. I think you're officially back to the first in chat champion. Hello, Olexi. Hello. Maximal minimal length of product of transpositions in Sn. Wondering about this problem. Couldn't find it online. Sure, it's probably an exercise. It's well known to any permutation. Can be written as a product of transpositions. Called permutation written as a product of transpositions minimal if cannot be written as fewer transpositions in symmetric group. What is the longest minimal product of transpositions? Hello, Julie. I wonder. Yeah, I wonder. I mean, I wonder if there's a slick way to compute it. The length, the maximal length element. Isn't it just the, because isn't the longest element just the product of all transpositions? Am I wrong? Isn't that the... Well, I guess it depends the order. Let's see the post. Curious how others would go about this. Maybe there's a simpler reason. Product of n minus 1 transpositions. Right. Nice. Nice. Well, I don't know if they're right, but... Hello, Mies Grimm. Isn't cycle decomposition always the minimal way to write each permutation? So you want the longest cycle form? Is it? Is it always the smallest? I could believe it. Yeah. How's their proof go? First show there are elements requiring at least n minus 1 transpositions. Right, and then show you can reduce anything bigger than that, I guess. Right, and then they just have an argument about reducing bigger ones. Yeah, cool. I am thinking about making some videos about the conjugacy classes of AN and SN. I think there's some really cool proofs there. I mean, there's a Galois theory course being taught at my university this semester, but I won't be TAing it. Kind of want to, but I have a role where I'm in charge of the Math Help Center, which is pretty cool. So I'm going to do that instead. Hmm. Dedekind cuts, come on. Dedekind cuts are inferior. Do Young diagrams. Yeah. Yeah, I could talk about Young diagrams. Um, yeah, I guess there's a lot to say about Young diagrams. Actually, there's a lot I don't know about Young diagrams. Um, what's the tea? It's coffee, Boris. Um, yeah. Uh, but yeah, I mean, there's also interesting, classifying. Well, I mean, the conjugacy classes are classified by the Young diagrams, and therefore classify the E-reps. I do have that book that I bought from Howe on representation theory of the symmetric group in particular. And I'm sure if I dig into that, I can find some juicy, fun new facts. I've been doing a lot of reading on stacks lately, but I don't know if I have anything interesting to say, any information to regurgitate. Trying to understand this stack of unipotent Langlands parameters. What can I say, though? What can I say? Am I familiar with Euler's pentagonal number theorem as a cube proof using Young diagrams? Interesting. Hello, Lucian. Hello. Euler's pentagonal number. Finally stayed up late enough to watch Office Hours. Well, I'm glad you made it. I guess I started a little earlier today too than in most recent history. Have I read Pursuing Stacks? I've not yet. I mean, maybe I should. But I also feel like, there's this balance between like, oh, should I go back and learn everything properly from the beginning in gory detail? Or, I'm trying to just like get to the point where I can understand the research that people are working on, like there's this one paper, where is it? Yeah. Like I was working backwards from between the coherent and constructible Langlands, and I arrived at this paper by Bensvie and Nadler, and I'm trying to understand. I'm trying to understand. Oh, come on. Yeah. But anyways, this seems like a nice paper, and it's like somewhat understandable. I mean, there's still a lot of things about derived algebraic geometry that I'm, quite unfamiliar with. But I'm like, I can sort of start to see it, And so the question is, okay, like would it be a better use of time? Would I understand these statements sooner if I went and properly learned all the definitions? Maybe. But maybe I should just squint my eyes and beat myself over the head with this paper. Motivation for motives. You feel like you should know a bit to be fashionable. True. I also feel like I should know a bit to be fashionable. Talking about stacks, what resources did I use to learn about them the first time? You looked online at Olson's book, but it seems like there are not too many modern textbooks. Yeah, there aren't too many modern textbooks. There's this one. Where's this? Well, I've got a few. I don't think this is where the first time I learned about it. So there's, this is a really nice. Is it this one? Stacks for Everybody? No, this isn't the one. Is it? No, not this one. Let me see. Let me pull open my stacks folder here. Vistoli. I misspelled it, but Vistoli is a pretty good one. Yeah, this set of notes is a pretty good one. I would check it out. I was also looking at this set of notes recently on algebraic stacks as well. Just reviewing it. I need to take a closer look. I still don't. I need to like sit down with pen and paper, you know. But I was just like reading it a bit before bed, like not very seriously. And there's one other nice document. There's one other nice document. I think it's on my desktop. No, I can't remember. I had some other thing on stacks. Let me find. Was it just this one? No. That's a whole ass book. I wish I had named this something reasonable and I would have remembered. Damn it, I can't find it. There was one really nice short note I saw that was about stacks. Oh well. Alper's lectures on YouTube are good for stacks. Nice. I did move. Yeah, to a new place where I don't hate my roommates. With green tars? Does tensoring your apartment preserve exact sequences? Tensoring by my apartment preserve exact sequences. Yes. I got it now, Rod. Yes. Yeah. Parasocial superfan gathering. Exactly. I do need to. I've just been busy working on other things, but I do need to get my life together and start selling you guys some merch. I also need to figure out what I would offer in a Patreon so that I can get you guys to give me money on Patreon. But I've been too lazy. I'm not money hungry enough yet. I just want to talk about math. But soon, once our parasocial bonds are nice and strong, I'll manipulate you emotionally into giving me lots of cash. Reaper, yeah, I do. I've not really used Reaper, though. I downloaded it. I do make music. I have some guitars and a keyboard in the corner. I don't know if you can see a little over there, but I've got my guitars and bass and stuff. But I haven't really recorded much at all. I don't know how to. Yeah, I'm not very good at the recording process. Wooden plank wall is kind of unique. Yeah, the rest of the apartment doesn't look so Ted Kaczynski, but yeah, it does kind of look nice. And I think this little corner we've cultivated over here with the plants and instruments, and I guess you can't see on the shelf. I've got some like antlers and stuff on there, so it's all very vibes and aesthetic. Yeah, yeah. Okay, I will try. Okay, this week I'm gonna try and make. I'm gonna try and make some shirts and hats or something. Shouldn't take very long, right? Basically, all I need to do is just like write a random ass commuting diagram that I think looks cool, and then print it. Waiting for the switch into applied PDs and ML could happen. Could happen. Oh, yeah. Sorry. One of these days I'll remember to do live chat. I probably missed some messages. That might be why. Top chat thing, yeah. Doing anything, should you give some problems to solve? Sure. But you're gonna give me some impossibly hard problem to solve. And by impossibly hard, I just mean a problem I'm not particularly equipped with to solve. Make one that goes around the entire hat. Oh, interesting. I'd have to see about that because I mean I was just making a bonfire, an account on Bonfire, and I don't know if I have the ability to make something go all the way around the hat. I guess we could do Galois cohomology. I just can't. Pi one of the line with two origins. Okay. Pi 1. What's the notation for the line with two origins? I don't know. Just draw that. Yeah, I don't know how to compute this either, though. It'd probably be better if I just opened up a Galois cohomology document and tried to compute it. You've seen my recommendation of a Luffy, but what to read after a Luffy to grasp the landscape of modern algebra? That's a good question. Well, papers. Number one, you should be reading papers, going to archive. Go to archive and see, what is... type in algebra and just start reading some of the abstracts and see, what sort of things you see. Okay, Brown algebras. Okay, Kahn's embedding problem, like make some notes, right? Okay, that's quantum mechanics stuff, but which is fine. So, but just start looking. Okay, Fukaya categories, right? So write down what some of these terms that you see. Hilbert schemes. Okay, so make some notes, and then go down a bit more. Okay, C-star algebras, right? So you start going and looking through all these terms, and then you see, something about Hilbert and A3, maybe that's also a Hilbert scheme. So then, okay, put another little tick around that. You go, okay, maybe Hilbert schemes, that's something that's happening. That's something I should read about. Spectral sequences for Hochschild homology. Oh, look, Fukaya categories comes up again. You go, oh, okay, so maybe whatever these Fukaya categories are. So that I think would be a good way to start getting a sense of modern algebra. I mean, yes, Edit Smith, you're right. You can't necessarily just go start reading and deeply understanding a bunch of archive papers right away. However, the question was about understanding what's going on in modern algebra. The only way you're going to understand what's happening is if you go to archive and you see what people are talking about. The other thing, too, is that at some point you have to give up on the linearity of reading, right? You can't just go, oh, I'm going to go from a Luffy to the very next book in the progression and the next book in the progression. Eventually, I'll finish this progression, and then I can start reading archive papers. I don't think that's the way things go. That's not how it works in grad school. You take you find a paper and you work your way backwards from like the words you don't understand, and you're like, okay, well, in order to understand section 1 of this paper, I got to go read up about what's a Borel subgroup, so I stand by my claim. I don't know uses of tame fundamental groups. You have a personal favorite trick which makes it trivial, and use this example to advertise. Okay, we might come back to it. A good continuation after Luffy is deeper into homological algebra or rep theory, which he doesn't cover at all. Yeah, that's a good point. Yeah, I'm not saying don't go read another textbook, but perverse Schobers is an actual technical term. Yeah, I guess so. Where was it? That was up at the top, right? The Nil Heka Schober. Yeah, let's figure. I'm curious. Perverse Schobers can be used to describe Fukaya categories, but are hard to axiomatize and construct. Interesting. Yeah, I mean, not only is it an actual term, but apparently they construct perverse Schobers. They're a concept of sheaf of categories. Well, there you go. There you go. Reading any papers nowadays would require more specialized prerequisites. Yeah, I mean, yeah, again, to be clear, reading almost any paper these days probably takes years of study, even once you've done an undergrad and a master's or something. Well, no, I mean, it depends on fields, right? There's some fields where you can start reading, some particular papers you can start reading in your undergrad or whatever. But, yeah, but the point is, like, how do you start learning? Well, you got to pick a paper in the field and sort of work backwards, right? You need to figure out what you're supposed to, what you need to learn. Yeah. You need to do rep theory for AlgQual, one of those random things you never learned but picked up by osmosis. Rep theory is beautiful. So enjoy your studying, unironically, every bit of it, because it's wonderful. Is easy using groupoid Van Kampen theorem, by the way. Oh, interesting. So are you thinking of it purely topologically? The line with two origins? Because I wrote et because I assumed you meant like the algebraic geometry line with two origins. That's the usual context I've seen it in. But based on what you're saying, it seems to me like you're considering the just the ordinary fundamental group. So how is that defined? Is it like you take the union of these and then you just identify the like two copies here for all x not equal to 0 and just do this quotient construction? And then what base point are we taking? I'm guessing away from the origin or at the origin. I guess, should it matter? Yeah, very weird space. Is it path connected? Yeah, I guess groupoid Van Kampen. Although we also have like an obvious choice of cover here, it seems like. No, but would it actually be a covering space? Algebra and search query would result in things related to algebraic geometry, topology, theory of algebras, operator algebras, you would miss things on groups, homologies. Well, you wouldn't miss things on groups and homologies, but I mean, look. Also, the thing is, these things are very intertwined, right? These fields are all very intertwined. But you could definitely go, and so like, yeah, by all means, if you're more particularly interested in group theory, go to group theory, right? Click on group theory, see what people are doing. Oh, sites and growth and deque topos is an introduction from Carmelo and Laforgue. Okay, gonna check that out. But yeah, go to group theory and look at all this other crazy stuff that shows up in group theory. I mean, yeah, these things are nice. What an amazing title. Breaking Bad Theories of Class S. Nice. Physicists always have more fun titles. Math titles are so boring, and I'm gonna be part of the problem. My next paper is gonna have a boring title, but it's just very literal, you know. But I'm not brave enough to not be taken seriously. Maybe once I'm an expert. Or yeah, if you're interested in homology, you know, go click homology, and you know, see things. Look, this came up in algebra and homology. This paper. So, yeah. Boris, are you talking about algebraic pi 1 or topological? Yeah, that was my question. You're not sure if it's good to catch landscape. Well, yeah, like I said, focus on the things that. Yeah, Boris, I'm still confused. You said that doesn't really answer the question. Fundamental group. So do you mean the étal fundamental group, defined in terms of like covering spaces of algebraic varieties? Or are you talking about the fundamental group defined in terms of like loops in a topological space? Good morning, Ken. Apparently some functional analysis has some relationship to representation theory. Oh, yeah, definitely. I mean, 100%. I mean, 100%. Like functional analysis is the whole way that you make sense of infinite dimensional vector spaces. Okay, there's a lot of ways in which functional analysis and representation theory interact. I mean, they're deeply intertwined in so many ways. But at the most basic level, like the thing that allows you to discuss infinite dimensional vector spaces is functional analysis. And if you want to study representations of a group with infinitely many elements, you're probably considering infinite dimensional vector spaces. And then in particular, often we want these groups to be Lie groups or algebraic groups, have some sort of topology on them. So now we're thinking about continuous operators on vector spaces, infinite dimensional vector spaces. So absolutely essential. Moreover, a big thing in representation theory and like Langland's program is like the L2 space on a group. Like the classical Langland's program is about the L2 space of functions on a group and representations that live in there. So you absolutely need functional analysis to make sense of any of this. So there, yeah. I mean, and this is just the tip of the iceberg. Like, there's no end to the interactions between these fields. I shouldn't read any more books. Well, Not exactly what I was going, but you know, I don't know. I don't know. I think there's an argument. Like, it's hard to say because at times I feel like my background should be stronger in certain areas, and maybe there's an argument I should spend more time. Should have built up more of a background. But then I could also imagine someone who just puts most of their effort into reading and understanding papers could really do incredible things quickly. So I don't know. Yes, yeah, exactly, Rod. Yeah, I mean, I've said it before. I said it again. Fourier theory, the basic Fourier decomposition is just representation theory. Actually, the fact that you can decompose a function into its Fourier series um, is that's just a statement about representation theory. Have ever looked into the fictitious field of order 1? How dare you, new wave infantry? F1 geometry exists. It's very real. Yes, I've looked into it. By the way, I don't know if you caught office hours the other day, but I did. You had previously asked about Dinkin diagrams. I did talk about Dinkin diagrams a little bit. So I think that was like 2 days ago. Yesterday or day before, I don't quite remember. Yeah. So, but yeah, F1 geometry is very cool. And it's the key to everything. Knapp's Advanced Algebra, yes. I do want to get myself a hard copy of that book because I have a hard copy of his Basic Algebra. Yeah, I would like a hard copy of that one. Interests are becoming more gauged towards topic like C-star algebras, Neumann algebras, operator algebras. Nice, nice, nice. Yeah. The line with two origins is path connected, but not locally path connected. The line with two origins is path connected, but not locally path. Yeah, so that would be trouble for covering space theory, right? Oh, it is locally path connected? Okay. I think we are gonna go soon. I've never heard anyone say the prefix fictitious. Topology line with two origins is usually used as an example of non-Hausdorff manifolds. Yeah. Compute the H1 of spec K in with z valued z mod n valued coefficients. Okay, we'll put this on the list for tomorrow. So computing pi 1 of the two origin line and computing H1 spec K, a to-do list with z mod n coefficients. Would love to hear more about classical Langlands and L2 spaces, etc. I don't work as much with the L2 space theory, but we could definitely talk more about it. But I definitely encourage you to go look up. What's a good resource for that? I mean, you could look at Getz and Hahn's book. You could look at Getz and Hahn's. Wait, it's the N, the H here. I don't remember. I'm so bad at spelling. The book used intro-level functional analysis very much. Takes the vector space with the underlying field RC. Yeah, and as a lot of Langlands does as well. I mean, there is also like, P-adic Banach spaces and stuff, but But I mean, representations of p-adic groups, there's still the theory of taking those over complex vector spaces. But yeah, okay, so this is my, this will be our official to-do list. And we'll get to it tomorrow. But for now, I gotta get back to my thesis. So